Okay, so statistics. So this is a new topic, so we will be having a test on this stuff once we finish learning all about it. This pack is quite big. I put it together yesterday assuming that we were learning everything in this chapter, but there are a couple of things that we don't need to worry about. So when we get to them, I will explain them. So, statistics. When looking at statistics, we need to collect data. You might say data, that's fine. There are different types of data. There is categorical and there is numerical. Now, maybe I should take a side step. Statistics. Have you all heard of statistics? Yes? So you may hear it talks about if you watch the news and things, and some people say, oh, well, this statistic and that statistic. It basically is looking at what has happened in the past and how we use that information that's happened in the past to perhaps predict what's happening in the future. So it could be that I try and find out how many of you have a pet. Okay? So I would do a survey and I would collect some data on how many of people in this class have a pet at home. And I would then perhaps say, right, I'm going to use that information. I found that 20% of people in this class have a pet. So I might assume that 20% of the whole of VHS has a pet. I might assume that 20% of the people in Bermuda might have a pet. But I'm using my data to calculate statistics to then make some calculations. Everyone happy that that's what statistics are all about? Yeah? So, the data we collect. So it could be, I might say to you, what kind of, what's your favourite subject? Okay? That would be categorical data. Because, well actually, there's only one option. I'm sure you will say maths. But that would be a category, so you tell me which subject is your favourite, okay? It could be, so here we've got occupations of people. How many people were doctors? How many people were nurses, secretary, cleaners? Okay? Here, the way we would represent that kind of data would be in a column graph, a bar chart, or a pie chart. They're the three main ones. Now, this one here is officially a column graph, but it's often known as a bar chart. So I'm not too concerned if you call this a bar chart or bar graph. Okay? It's just officially in a column, goes up and down, hence the slightly different name. We've all seen pie charts before. I think we did those in year 8 as well. Yeah?
So we can call column graphs bar graphs?
Yes, that's fine.
They're just going
Yes, this is a different direction. So numerical data. So as it sounds, this is data of numbers. Okay? So for this kind of thing, it would be how many siblings you have. Okay, your answer to that question would be a number. How much pocket money do you get? That would be a number. How tall are you? That would be a number. What size shoes you take? That would be a number. So this is all numerical data. You understand the difference between categorical and numerical? Yes? Now, statistics-wise, if we're calculating calculating statistics, we wouldn't be able to do much with categorical data. Okay? We wouldn't be able to say too much. You'd probably be able to put in a graph or a chart and say what was the most popular thing, but that's pretty much all we can do. Numerical data, we can do quite a lot with it. Now, within the numerical data, we have what we call discrete data and continuous data. So discrete data would be something like number of somethings, number of pets, number of siblings, shoe size. That would also be a discrete thing because it's just a one straightforward answer. Okay? Because you are either a size 7 or a 7.5. You're not a 7.26. Does that make sense? Yes? However, the length of your foot would be what we call a continuous measurement. Because that is can be anything. Okay, so it can be any number. And as it says here, so discrete data takes distinct values, usually as a result of counting. E.g., the number of goals scored by a football player. Continuous data can take any value and is usually the result of measurement. So, e.g., the weight of a pumpkin. Or the size of a pumpkin. Okay? So, we measure continuous data, we count discrete data. All good? I might set you off doing some work. Alright, so we're now on to more specifically discrete. So we're focusing on discrete numerical data. So remember, numerical data is either discrete or continuous. Okay? So if it's discrete, we often collect it using a frequency table. Now, I didn't draw a frequency. Oh, no, there's one here. This here is a frequency table. We've all seen these before. Yes? So we've got our options here. So whatever our options may be. So these options are between 3 and 7. So let's hope it's not your percentage test. That's a joke.
Oh wow, they make it better. I don't get it.
You can't say that. I said, well, let's hope that we haven't just tallied how many people have got 3% or 7%. That was a little joke.
Where is it? Hopefully no one got that on their
Next
text.
lost it.
You mean like the test that we took?
Yeah.
Yeah.
We took.
You guys
Don't say it.
Oh, no.
No, exactly. That's why it's a joke, because people didn't get between 3 and 7%.
Oh, are you sure, my parents? So we
got 8%.
Right, okay. So, obviously this is some other kind of data, and that 2 people have 3 of them, 9 people have 4, and we all know how the tallies work, don't we? Yes, so 4, and then the 5th one crosses it out. Perfect. So we may collect our data using a frequency table. We may display it in a column graph or a dot plot. To be honest, dot plots aren't very common. Okay. Now, this is where I got a little bit carried away with myself, and I included 7-leaf plots. Now, I think you've done 7-leaf plots already, haven't you?
Once in your cell.
I don't even know what that is.
I don't remember doing that.
I remember.
Oh, I remember barely then. Oh, yes, that was a giant.
So here, our stem
Oh, yeah.
would be the first digit of the number, and our leaf would make the second part of the number. So if I was to talk about this number here, okay, this represents 27. Because this is my stem and that's my leaf. Does that make sense?
No.
So this number here
Would be 43.
would be 43.
Where did you get the numbers from?
It's in front of you. You can look at the sheet.
You got the numbers from other data, from those data up there.
Yes.
Okay.
Yeah. Now, so the other classes are not learning about stability diagrams, so I'm going to sidestep from that and not stress you out by looking at them again. You should have learned about them and you should recognize them.
So, how do you know which numbers to write next to?
Alright, so this is my data that I collected. So I went and did some kind of survey, and they're the numbers that I collected. Okay, I can see they range between 9 and 51. Okay, so because they range between 9 and 51, I've chosen to represent that in my 7-leaf diagram. Because I have 9 and the rest of them are all 2-digit numbers, I have to have 0 as part of my stem. And then obviously I go up to 5 to represent 51. Yes. And then I just go through my data. So if I wanted to fill it in, hang on. So if I would take 28, I'd find my 2 and I'd write my 8. Yes? And then I would do 47, so that would be 7 here. And then you just go and do the 39, 23, and so you put them all in. Okay? So you list them all out. Okay? Then, this is my ordered one. So the only difference between this one and this one is that my numbers go in ascending order. So they start at the 1 and finish at the 7. They start at 3 and end at 8. Yes? So that's the only difference between this one and this one. Now, for a 7-day program, you must have that. Because my numbers here could have been 3.1, 1.1, 2.6. Right, so they could have all been decimal values. If that was the case, then this here would say 5/1 is 5.1. So you would know that that's what it represents. Okay? So your scale here always tells you what your values represent. But these numbers are linked together.
So for that one, do you only do the biggest number? To find the scale?
No, you can do anything. You can choose anything. You can say that 2/8 represents 28.
You have to do.
But you must have some, no, you just have to choose one. Just any one. Okay? Right, but as I say, this is not what we need to worry too much about. So if you want to have a look at that, that's fine. But we're going to move straight on. Okay? So you may want to write a little note next to it, not needed for the test. Because later on, some of you might go, oh, now I haven't learnt that, I guess spend 4 hours learning it, so I must have been away that day. And then you'll forget that we didn't need to learn it. So you don't need to learn about 7 leaf diagrams.
So this blue is not needed as well, right?
Correct. Yes. Is it 4 pages that needed?
No.
No, you need to know, you need to recognise that the tally charts, the frequency diagrams, but you don't need to worry about 7 leaf diagrams. So anything below that. Okay? I'll just pause it while we Alright, so describing the distribution of data. Describing the distribution of data. So this is often considered in reference to the centre of distribution. So if we were to draw this data in a column graph, and if our data looked kind of like this, so there's obviously the middle of it, and you can see that it's kind of symmetrical around that middle point, we would say that this was symmetrical. If your bump in your data is a little bit to the left, we would say it's positively skewed. If your bump is to the right, we would say it's negatively skewed. Now, this is just terminology for you to recognise. It's unlikely you to have many questions that come up like this, but it's just information for you just in case something does. So let's work through an example together. So I put the, oh, it hasn't come out.
Yes, but not that well.
Well, I said very well. Alright, so we're going to display this information in a column graph. So, our number of visits and our frequency. Now, do we all know which way round things should go? Where would the number of visits go? Would that we go on the vertical or the horizontal?
Vertical.
Alright, it's okay that you don't know, but don't shout out stuff if you've got no idea. Alright, so frequency, this is a tip for you. Frequency. Do you understand the word frequency?
Yeah.
Frequency means how frequent, how often. Okay? So frequency will always be your vertical scale. Okay? So frequency will always be the vertical scale.
The microphone fell down.
Oh, it should be okay. It should still be it's close enough. Maybe you can pick it up. So it's going to be crashed. Alright, so my vertical is going to go from what to what? What's my highest frequency number?
9.
9. So I need to go from 0 up to 9. Now notice I'm deciding this information before I've even drawn anything. Okay, so I can see that I need to go from 0 to 9 on my frequency. What do I need to go on my number of visits? Not a trip. 0 to 8. Okay. Now, with these zeros, for these ones, you're actually going to label in the bar. So we're going to have, here's our horizontal thing. We're going to have 0, 1, 2, 3, 4, 5, 6, 7, 8. So notice I've labelled in the middle of the square. This is my frequency, and I'm going to say 1, 2, 3, 4, 5, 6, 7, 8, oh, 9. That's the one I'm saying. 9. Now, for these ones, where have I labelled? I've labelled the actual lines. Okay? So these ones I've labelled in the middle of the bar, in the middle of the boxes. These I've labelled on the lines. Where you label them is important. So if you're thinking, oh, what's the ground different about not the distance? These do that. Right, then what we're going to do is we're going to draw a column graph. Now, my column graph essentially is going to be 6. It's not very big. So we look at my data. So for the 0 digits, what's the frequency of that? 0. 6. So I need to draw a bar that goes up to the number 6.
Just a line.
I'm just going to draw a line because this isn't very, this isn't a big paper. Well, ideally it would be a little bar, but you don't need, you want gaps in between them, so. And then for the 1, where does 1 go up to? 8. So 1 goes up to 8. 2 goes up to 9. 3 goes up to 7. 4 goes up to 6. 5 goes up to 4. 6 goes to 2. 7 goes to 2. And 8 goes to 1.
What about 9? Wait, there's no 9.
So now it's cool. Oh, and now you draw a hump over there.
Okay, so then what we do is we draw, and that's where it says, we draw the hump over it. Okay? So it doesn't have to be perfect.
Looks like a roller coaster.
Now, if my data was symmetrical about the middle, what value would this middle big hump be? Looking at my numbers.
4.
It would be around 4, yes? My hump would be at 4. Why do I think that? Because I've gone from 0 to 8. So halfway between it would be at 4, yes? 3 or 4, yes? Is my hump at 4? No, my hump's over here at 2. So how would I describe my data? Does it look like this, or this? Which one is it? The first one, the second one, or the third one?
Second.
Money? Second one. It would be the second one, so we would say it was positively skewed. Do you all see how we did that?
Yeah. Do we have to draw the hump?
You don't have to draw the hump, but it may help. So we would say that part B has asked for the describing the distribution, so I would say it is positively skewed.
Does it have to touch every?
No, you just do it and give it on to it.